Okay, today we are going to take a look at something called the average value theorem. So this is just a little topic that we couldn't fit into the rest of the year, so we're going to put it here at the end. Let's go ahead and just draw any generic function f that looks sort of like this, and then let's quarantine it off between the interval a to b. Okay, so let's pretend for the moment that these represent stock prices. So for example, you don't have to write down these numbers, but at time equals a, let's say the stock was worth $10, and now over here, let's say it's worth $7. And notice there's a lot of fluctuations. It'll kind of go down and then up a little bit. So the question is, how do I find the average value of the stock? So what I'm looking for is f average. Okay. Well, it's actually very intuitive, because how you find the average in regular situations is you add up all the values and you divide by how many values you have. So in this case, to add a continuous function, or the values of a continuous function, we're actually going to integrate from a to b f of x dx. So what this does is it adds up all the values. Now you might wonder, well, how many values are there between a and b? Well, it should just be the gap. So b minus a tells me how many I have between a to b. So this is what's known as the average value theorem. We're going to apply it to an example, but before we do that, I want you to leave a little bit of space, because there's going to be one more implication we'll look at in a second. Our first example, I'm just going to pick a function. F of x is equal to 2x squared, and then I'm going to go ahead and pick an interval, let's just say from 1 to 4. So keep in mind the picture of what we're attempting to do here. So what I have is 2x squared, which is just going to be this random parabola. Okay, and I'm just going to look between the interval from 1 to 4, and I want to know what the average value is in that interval. Well, according to the formula, to get the average value in that interval, I'm just going to integrate from 1 to 4, 2x squared dx, so that's going to add up all the values, and then I'm going to divide by the gap, 4 minus 1. So in this case, the top integral becomes 2/3 x cubed from 1 to 4 all over 3. Okay, if you work this out, the answer you get will be 42 over 3, which reduces to 14. Okay, there is one other implication. So let's go back to the first page where I have this formula. And what I'm going to do is I'm just going to rearrange this a little bit. So I'm just going to move the b minus a over to the other side. So alternatively, I can say the following. I can rewrite this as b minus a times f average of x is equal to the integral from a to b f of x dx. So let's understand what's going on here, because there's actually some big implications. So what we know is this is just the area under the curve. So area under f, technically from a to b. So what it is, lightly, is it's this area. Now let's take a careful look at the second part. This right here is just the gap. So that's really like a base. It's really this base right here. And this, if you think about it, is a height. Okay, so base times height will just give you the area of a rectangle. The average height, I'm just going to kind of guess where the f average is. Let's just assume it's there. So let's assume right there that's f average in this picture. What we're saying is, if you find the area of this rectangle, which I'm about to draw, it is exactly the same as the area under the curve, or the integral, which kind of makes sense because you're leaving out some area and picking up some extra area. So there are two implications. Implication number one is that the area under f is equal to the area of a rectangle with height f average. Pretty remarkable. The second implication, kind of just based on the picture, is that f average of x has to occur in the interval. Okay, so in other words, if our stock price started at 10 and then drop to 7, and whatever the average was, it has to occur somewhere between A and B, so the x has to be here. So what we can ask is, if we go to our next or our previous problem, we can actually say find the value of x where this occurs. Okay. Okay, so again, what we're saying is f average at some point will equal f of x on the interval 1 to 4, somewhere in between there. Okay. So our f average we got was 14, our f of x was 2x squared, so if you solve for it, you'll get that x is equal to plus or minus square root of 7, which, surprisingly enough, radical 7 is somewhere in between here. Okay? So let's look at a second example. And here's our second example. We are going to look at a function which is e to the 1 over x, all over x squared. And let's just look at the interval 1 to 3 to keep it simple. Okay, what I would like you to do is integrate this by hand, but then at the point where you actually have to plug in the numbers, you can go ahead and use the calculator. You need to find two things. You need to find f average, and you need to find the value of x where that occurs. So before moving on to the next video, I want you to just pause and try to work that out on your own, maybe in the next 5 minutes or so, before clicking next at the top right.